I am Anil Kumar sharing with you important question from test point of view. You know what is curve sketching, but sometimes you need to know much more to really sketch the graph of the function given to you as shown in this particular video. In case you want to learn from me, you can always send an email on the address given. Let us now enjoy the journey of success. Here is the question for you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a test question which is related to curve sketching. I'm saying related to since you have to analyze the function first, get your own values, and then sketch. It gives you a flexibility, and it is really a very good question from test point of view. So we're looking into how do we graph from the given conditions. We are given a function f of x equals to 2x plus 4 divided by x square minus a square. Find the conditions on A such that f of x will have critical points. Sketch graph of f of x with two critical points. So that is the condition given to you. I will like you to pause the video, analyze the situation, and then select a value of A to sketch the graph. Here is how I think about it. Well, in case you want to learn from me, you can always send an email on the address given. Now, when we say we want a condition on this function that will have a critical point, in fact, we have written points, it really means what? It means that we're trying to find the derivative, and that should be equal to 0. That is what it means, right? So let's begin by finding the derivative as such for the given function. So what is the derivative of this function? Well, definitely we'll apply the quotient rule. And so we get the denominator square, which is x square minus a square whole square. Derivative of 2x plus 4 is 2. So I'm multiplying that with the denominator, which is x square minus a square, right? Minus the numerator, which is 2x plus 4, times the derivative of denominator, which is 2x. Right? So you know the rules, so we're not getting there. We have the derivative, and now we have to equate this derivative to 0. That is the condition, correct? So now let's look into the numerator part and see what is the condition for A so that we do get a 0. So now let us try to simplify numerator. So what do we get? So let's open this bracket. So we get 2x squared minus 2a squared. And here we get 2 times 2 as 4, x squared minus 4 x squared. And we have minus 4 times 2, which is 8x. And we want to equate that to 0, correct? So that is our condition. So 2x squared minus 4x squared will give us minus 2x squared. So we can write this as minus 2x squared. Since a is a constant, I'll write it at the end. And then we have minus 8x. And we have minus 2a squared equals to 0. We can take minus 2 common. In that case, we get x squared plus 4x plus a squared equals to 0. Okay. So that becomes the condition for our equation. And now, to have a 0, what is the condition? Well, you remember b squared minus 4ac should be greater than 0, right? b squared minus 4ac, which is the discriminant, should be greater than equal to 0. So if it is equal to 0, we get 1, 0. If it is greater than 0, we get 2, 0, right? So substitute this condition, right? So the discriminant d should be greater than equal to 0. So let's put that condition here. In that case, b is 4 for us, a is 1, and c is a squared. So b squared minus 4ac will be what? So we are looking for 4 squared minus 4 times a is 1 and c is a squared. We want that to be greater than equal to 0. Perfect. So that is 16 minus 4a squared to be greater than equal to 0. Or we can say that 4a squared is on the other side, right, is less than equal to 16. Now if I take square root, in that case, what do I get? I get 4 on this side, so square root both sides. Now look here, we are doing square root both sides. Now can you tell me what is square root of a square? That is very important, right? Many times students do not answer this properly, and that is where the mistake happens. Well, square root of a square is absolute value of a, correct? You get the idea. We could have divided this by 4, and so I will first write this equation here, rather inequality, as a square less than equal to 16 over 4, which gives me a square is less than equal to 4, right? Now if I do square root, in that case, what happens? So when I say square root, then square root of a square is absolute value of a, and square root of 4 is 2. You get the idea. So absolute value of a should be within plus or minus 2. That is to say that a is between 2 and minus 2. Right? This is the solution of the inequality a square less than equal to 4. Right? Clear? How did we get that? At this stage, we did square root on both the sides, correct? And you know, square root of a square is absolute value of x. So that is the condition which we get on the given function. Is that clear to you? So coming back to our question, which says, find the condition on a such that f of x will have critical points, right? So if I want more than 1 point, then it should be less than, right? But anyway, in this case, I do get a condition that absolute value of a is actually less than 2 or equal to, will have one critical point. So we have done part A of this question. I hope this concept is absolutely clear, right? Now, sketch the graph of f of x with 2 critical points, right? So if I want 2 critical points, definitely I have to take a value which is less than 2, right? So then I say, well, let a equals to 1. Is it clear to you? So I'm taking a as 1, and now I have to sketch the graph. So I'm sketching the graph of f of x equals to 2x plus 4 over x squared minus 1. Now clearly we could factor numerator, denominator, we have 2 times x plus 2. And here we have x plus 1 times x minus 1, right? So from here, many things are clear to us. To sketch the graph, we can draw the asymptotes at plus and minus 1. So here is the asymptote at minus 1. And then we have another asymptote at plus 1. Correct? And if I put x equals to 0, I get the y-intercept, which is 2 times 2 is 4 divided by minus 1 means minus 4, right? So 1, 2, 3, 4. The y-intercept is right there. And we have the x-intercept because the numerator will be 0 at minus 2. So x-intercept is right there. You get the idea. So we have an x-intercept. We have the y-intercept. And we know the horizontal asymptote. So let me write down what we have from here. So from here we have vertical asymptotes at x equals to plus minus 1. We have a horizontal asymptote, which is y equals to 2. So y equals to 0, sorry. Since the degree of numerator is 1 less than denominator, so y equals to 0. So let me draw this horizontal asymptote also. Correct. So we have this horizontal asymptote, which is y equals to 0. And these are the vertical asymptotes, x equals to plus 1 and x equals to minus 1. Correct? X and y intercepts also plotted. Now, we have the first derivative. And let's look into our first derivative, which we found is 0 for a equals to this, right? So we have this derivative. We can plug in 1. Now change this equation. Plug in 1 for derivative, right? So the numerator will really become, when you plug in 1 here, simplify your expression. So when you do that, now I'll say that we have basic parameters. Find the first derivative for the function. Let me write down. So the first derivative now for the function will be x squared minus 1 whole square, and the numerator derivative is 2 times x squared minus 1 minus 2x plus 4 times 2x. Now this can be simplified. When you open this bracket, you get 2x squared minus 2. And on this side, you get 4x squared minus, just as we did last time, right? Minus 8x over x squared minus 1 whole square. Now that can be simplified. So we have minus 4x squared minus 2x squared is minus 2x squared. So we have minus 2x squared minus 8x and minus 2 over x squared minus 1 whole square, which can be simplified as minus 2 is common. And we get here x squared plus 4x plus 1 over x squared minus 1 whole square. Correct. Now from here, you can find the critical points. Solving this quadratic equation, right, and finding the value of x, substitute that to, you can find the critical number from here. So I'll recommend you to solve this further, right? Find the critical numbers, which will be at x equals to, let me write down here a bit smaller, we have less space here, minus 4 plus minus square root of b square, which is 16, minus 4ac, which is minus 4 over 2a, which is 2. Is that clear to you? So that gives you the 2 points on x, which will give you the turning points, right? Because we have two critical numbers here. And based on that, I'll suggest analyze further. Okay, so I'll leave it for students, right? So continue. So you know the strategies to graph the function. So analyze the first derivative and the second derivative, right? So you can see the behavior of the curve, and you can see it goes through this point, but then has to turn back to get to the graph itself. So what you find here is that it has to go like this. Do you understand this part? So that will become one of the turning points for you. And the other turning point can be seen at this local. Do you understand this part, right? And on the right hand side, you get a graph which will be kind of like this, right? So I'm just sketching the graph for now, giving you the important aspects. However, I'd like you to analyze first derivative to find local maximum and minimum, right? And then analyze the second derivative for concavity. So you can see very clearly that the graph is concave up in these two portions, right? And concave down in between, plus and minus 1. Perfect. Which we'll get from the second derivative result. So what I've done here for the convenience of all the students is provide them the graph with the values. You see this graph, right? So you'll get a similar result. Perfect. So that's a kind of result for you. So you can go ahead to rest of the calculations. I hope the concept is clear, right? So the idea was to understand how do we calculate this value of A. That was the main thing. And then how can we fulfill the given condition? Sketching the graph is the easy part, which you have been doing in curve sketching a lot. So in addition to that curve sketching, we could actually complicate your question as shown here, right? So if you do not take the right values of A, in that case, even if you know how to sketch a rational function, you will not be in a position to sketch it. So that's kind of important to understand. So these are the type of test questions which help you get more than 90% marks. And in case you're looking for something like that, you can always contact me on the email address given. I can provide you some guidance to help you get better marks. I hope you enjoyed this journey of learning. Feel free to provide your suggestions and comments. If you like and subscribe to my videos, that will be great. Thanks for your time and all the best.